This is our first video on our unit in sequences and series. Sequences and series underlie a lot of the foundational math and the development of calculus. So especially for those in engineering or other STEM fields where you will see calculus in college, sequences and series really provides a nice introduction and foundation upon which to build that later learning. So to get started, our first lesson is going to be about arithmetic sequences. So we want to be able to identify the properties of an arithmetic sequence and determine its explicit rule. And the reasoning is because arithmetic sequences are the simplest type of sequences we can study and will lay the groundwork of our understanding for the whole unit. So we're just going to start by a couple definitions. So a sequence is an ordered list of numbers. It has a first term, a second term, and so on. In math, a sequence is more precisely called a function with domain the natural numbers, 1, 2, 3, and range the real numbers. And so we also have sequence notation. So we might be more comfortable or familiar with function notation. So function notation has something like f of x equals to an expression. And so we can say that f is our name, x is our variable, and our expression is the rule for evaluating. So if we want to evaluate something like f of 2, we plug in x equals 2 to the expression. Sequences and series also have their own notation. Today we're just looking at sequence notation. Sequence notation is a sub n, and it's also equal to an expression. And so a is the name, n is the variable, and our expression is the rule for evaluating. In regards to sequences, we sometimes call this the explicit rule. So we can represent a sequence as a list of numbers or as a formula. With an explicit rule, that gives us the general term the sequence. So let's spend a little bit more time talking about this AN, specifically representing sequences as lists of numbers. So if we think of our counting numbers n, we have 1, 2, 3, 4, so on, to some number that we're going to call I, and so on. So we can think of this as our input. So rather than, let me just back up a second. Let's call this our input. And so we have some number n, and then we have an output, which is A1, our first term, A2, our second term, A3, our third term, A4 is our fourth term, and then we have that AN, which we can express as a formula. So the subscript is our input, our variable. It tells us the place in the sequence. So this is first place, then second place, third place, fourth place, and then we get to this thing that we call nth place, where n is just any number taking the place of that variable. So this has been video just introducing basic terminology of sequences. In our next video, we're going to talk about arithmetic sequences, but there's one last thing to talk about in this video. And and that is sequences may be infinite or finite. So a single entry in a sequence is called a term. So an infinite series is one like 1, 2, 3, 4, 5. I think I said series when I meant sequence. So we represent going on forever by these 3 dots. It goes on forever. A finite sequence is something like 1, 2, 3, 4, 5. No dots means it does not continue. So keep in mind that our sequences could be infinite or finite. We're usually going to work more on the side of the infinite sequences, since that tends to be richer mathematically. But the finite sequences are definitely still important. Most of what we say about infinite sequences will also apply for finite and vice versa. Where the distinction is important, I will make sure to mention it. But as I said, mostly we'll be working on infinite sequences.